All right, good evening, 4-3. Tonight we're going to continue working on Module 3, and we're going to be starting with Lesson 3. Demonstrate understanding of area and perimeter formulas by solving multi-step real-world problems. So guys, basically, we're going to be taking these problems, we're going to be reading it, we're going to be drawing it, and to see if it really, kind of checking it over to see if it really makes sense. Because we want to apply this area and perimeter to real world problems. So let's get started. So in earlier grades, we focused on the read, the draw, and the write. Now in 4th grade, we're going to be continuing with the drawing, because that's a great way of understanding what's happening. We're going to solve it. But then we're going to see, does it really make sense? The first problem we're going to focus on tonight is about Katie's wrapping paper. And we see that Katie's wrapping paper is 2 times as long, and she wants to make it as 2 and 3 times as wide as the box that she was wrapping. And we see that her box is 5 inches long and 4 inches wide. And they're asking you to find the perimeter of the wrapping paper that she will cut. Now, guys, this is kind of flip-flop, because the first part that we need to answer and focus on, and we need to draw it out, is the second part right here. The box was 5 inches long and 4 inches wide. So we need to do that first before we get to the second part, which is on the top. They kind of flipped the question on us. So let's make a box, a rectangle. And this down here is 5 inches. And over here is 4 inches. But now if we go back, and we go back to that second part of the problem, they're asking you 2 times as long and 3 times as wide. So we want to double that first rectangle that we make. So we're going to double it. And this becomes now 5 inches. This is the length. And now we're going to make it 3 times as wide. So we're going to triple the width. Sorry for my horrible drawing, guys. All right. I got to do a better job here. Sorry about that. All right. Let me clear that up. I apologize. Okay. We tripled in the size. Oops. Sorry. Made too much. I'm just messing up here tonight. Okay. So now we tripled it. And this one is 4 inches. And this one becomes 4 inches. All right. So now we need to find out what our width is and what our length is. Our width, 4 and 4 and 4, because there's 3, so it's 3 times 4. This becomes 12 inches. And down on the bottom, our length becomes now 10 inches. So now in this word problem, it's asking you, what is the perimeter of the wrapping paper that she cut? So we know with our formula, we need to have our perimeter. So what's that formula for perimeter again? Well, it's P equals 2 times the length plus the width. So now we need to plug in those numbers. Bring down our P. P equals 2 times. The length is 10 inches, and our new width is 12 inches. Let's continue it. 2 times what's in our parentheses, it's 22. And because we have another side of 10 and 12, that's why we're multiplying it by 2. P equals 44 inches. Guys, basically what we're doing here is that we are looking around her new cut of her wrapping paper, around this wrapping paper, would be 44 inches. Our next problem is about Alexis and her red paper, and she wants to put a blue piece of paper on top of that red paper, and we want to find out how much red paper is visible if we're covering it with the blue paper. So this problem is so confusing. So let's check this out. Let's see. Alexis has a rectangular piece of red paper that is 4 centimeters wide, and its length is twice as its width. There's that comparison again, twice. She has a blue rectangular piece that's going to be on top, and that is the blue paper on top of the red, and that's measuring 3 centimeters by 7 centimeters. So the question is, how many square centimeters of red paper will be visible on top? So let's start making our red paper. And our red paper is about 4 centimeters wide. All right? And we have to make its length is twice as its width. So if our width is 4, we have to make another box. And that one is going to be 4 centimeters also, because it's twice as its width. So here's 4 centimeters, and here's 4 centimeters. So now we have a width that is 8 centimeters. But now Alexis has decided to take that blue paper and put it on top of the red paper. But this red paper is 3 centimeters by 7 centimeters. So let's kind of go about right here. And since it's 8 centimeters with the red, we only get 7 centimeters. And we're going to stop it right about here. So this section is covering the red, and this is 3 centimeters, and the bottom is 7 centimeters. So if we really kind of get close in and look at this, that is, the blue is covering the red, and it's 3 centimeters. The width and the length is 7 centimeters. So now they're asking you how much of the red paper will be visible on the top. So they're really asking you for this right here. How much of this is going to be visible? How much of the red paper is going to be visible? Well, in order to do that, if you look back into the problem, it says square centimeters. And anytime we're talking about that square centimeters, we're going to be talking about area. So we need to find the area first of the red. So let's look at the area of the red. And the red, again, is over here, and this is going to be 4 centimeters times, when we had to make it twice its width, so it is 8 centimeters. Okay, so A equals 4 times 8 is 32 centimeters squared, because we're talking about area. And then now we have to find the area of the blue. And that A equals length times width. We look at the blue, and A equals the length, which is this 7, and then the width is the 3. So we have A equals 21 centimeters squared. So we have found the area of the red, and we found the area for the blue. But now we need to find out what is left over, that part that is not covered by the blue paper. So we need to find that part. And how we do that, remember, here's the word left over, the word's left over, which meaning we're going to be subtracting. So if we take 32 and we subtract it with the area of the blue, which is 21, we get 11 centimeters squared. So how much is visible on the top, that is the red paper, is 11 centimeters squared. All right, our next problem is the length of Marshall's rectangular poster is 2 times its width. If the perimeter is 24 inches, what is the area of the poster? So look at this. They're giving us the perimeter, but we have to find the area. And they're really not giving us much information, except that they want to know the length, and that the width is 2 times what the length is. So 2 times what the width is. So the width, so if we're drawing a line here, this is going to represent the width, and so the length is 2 times its width. So here's the width, and we're going to make a box here, and we're going to make the length 2 times the width. So here, this is the drawing that demonstrates the length of Marshall's rectangular poster is 2 times its width. So here's the length, here is the width. We doubled it. So how to figure this out? We see that this, we're going around, is 1. We have another one, that's 2. We have another one that is 3, 4, 5, and 6. So we have 6 pieces. Now we also know that they're giving us the perimeter, and the perimeter is equal to 24 inches. So that means if we go around this whole rectangle, we are going around 24 inches. So we need to see that we've got 6 pieces, and this is equal to 24 inches. If we walked all the way around those 6 pieces, we would have 24 inches. So if we have 6 pieces, and we know that we're walking around 24 inches, we would divide 24 divided by 6 would give us 4. So 1 piece is equal to 4 inches. So over here, this width is 4 inches. And down here, this whole section is 8 inches. Now, how did I get 8 inches? Well, because this part is 4 and this part is 4. 4 plus 4 is 8. So if I wanted to see if that really made sense to me, I would want to actually go back and try to see how did we get 24 inches if now we have these numbers of 4 inches and 8 inches. So let's look at see if this all making sense, because we really have to check to see if our drawing and our solving makes sense to us. So our perimeter is equal to 2 times the length plus the width. So P equals 2 times, and now let's fill it in. The length is 8, and the width is 4. So P equals 2 times 8 plus 4, which is 12. And if we multiplied that, that would give us 24 inches. See, it did make sense. It did work out because they gave us a perimeter of 24 inches. We plugged it into the formula, and it did give us 24 inches. But that's not what the question is asking us. It's now asking us for the formula. So we did all the hard work by using the drawing to help us. Now let's just solve it, find the area. Now we know that the area of a rectangle is A equals length times width. All right, so let's just plug it in. A equals, what's the length? The length is 8. What's the width? It's a 4. So A equals 32. And we're talking about inches. And we need to make sure we put that squared, because that is the measurement that's going on inside our rectangle, not the outside. The perimeter is around and the area is the inside. So we have 32 inches squared. So we were able to answer this question. And we were able to answer this question with using the help of the perimeter, and the drawing helped us also. All right, guys, now you give it a try. All right, looks like you got two things going on in here. A rectangular poster is 3 times as long as it is wide. A rectangular banner is 5 times as long as it's wide. Both the banner and the poster have perimeters of 24 inches. What are the lengths and the widths of the poster and the banner? Next problem. The length of a rectangular desk is 4 times its width. If the desk's perimeter is 30 feet, what is the desk's area? Well, I hope you had some fun tonight, guys. I know they're challenging to think about, but remember, we want to draw out our problem, we want to solve it, and check to see if it makes sense. Have a wonderful evening.